Tile-based renderers, when mobile GPUs play by different rules. Hello and welcome to episode number 30 of the Unity Performance Task Force podcast. I'm your host, Ruben from TheGameDev.Guru, and as usual, I'll kick things off with a question for you. Have you ever deployed your Unity game to Quest or mobile, opened RenderDoc, and seen something called Final Blit eating up 7 milliseconds of your precious frame budget? Sounds familiar? If so, this episode is for you. Today we're diving into tile-based rendering and why it matters to anyone targeting mobile platforms, Quest, or even some integrated GPUs. Now before we go further, let me clear up a misconception. If you're thinking, I only develop for desktop, I can skip this, hold on. Not all standalone platforms use immediate mode rendering. Some integrated graphics cards, Ryzen APUs, certain Intel chips, they're tile-based too. So even if you're shipping to Steam, this might still affect you. Here's the deal. Memory is expensive in all senses. Expensive to manufacture physically, expensive to design, expensive to use. Every time you move data between hardware components, you burn performance, you burn power, you generate heat. That's why memory hierarchies exist. Slow but large storage at the bottom, fast but tiny caches at the top. You can't have capacity, speed, and low cost all at once. On mobile, this matters even more. Limited power budgets, small form factors, less surface area for heat dissipation. You're working with constraints desktop never faces. That's why mobile engineers have spent decades finding ways to reduce memory bandwidth usage. And that's where tile-based rendering comes in. Let me paint you a picture. On desktop, we do immediate rendering. Think of it like painting on a canvas. You paint the whole scene in one go, left to right, top to bottom. The entire frame buffer lives in memory, you render to it directly. On mobile, we split that canvas into tiles. Imagine dividing your screen into a grid, maybe 32 by 32 pixel chunks. Now instead of rendering the whole frame at once, you render one tile, write it to RAM, move to the next tile, render it, write it to RAM, and so on. Why? Because a 32 by 32 tile fits in the GPU cache. You're not shuffling massive frame buffers back and forth. You keep everything local, in fast memory, and only write out when you're done with that tile. This saves memory bandwidth, saves power, saves heat. It's brilliant engineering for constrained devices. But here's the catch. That operation, copying a tile from the GPU cache to RAM, that's called a resolve. And resolves are expensive, very expensive. We're talking 0.5 milliseconds per buffer per frame. Multiply that by multiple render targets, and you're in trouble fast. Let's talk about when resolves hurt you. Real-time shadows. You know how shadows work, right? First you bind a shadow map texture, then you render the scene from the light's perspective, writing depth information. Then you store that shadow map in RAM. That last step? Resolve. Expensive, unavoidable if you're doing real-time shadows. I'll show you the workflow. You open RenderDoc, you capture a frame from Quest. You see the main light shadow pass, you drill down, draw elements, more draw elements. You're rendering into a temporal buffer, a 2K by 2K texture. And at the end of that pass, Unity has to resolve it. Copy it to RAM so you can use it later to apply shadows. That's why I always tell you don't use real-time shadows on mobile. Bake them. Use blob shadows. Use any alternative you can think of. Because every shadow map is a resolve, and every resolve is memory bandwidth you can't afford. Deferred rendering? Even worse. You've got multiple render targets. Diffuse, normals, roughness, maybe more. Every one of those buffers needs to be resolved. On a 4K screen, that's gigabytes of data moving around. Tile-based renderers hate that. So if you're doing deferred on mobile, rethink your life choices. Post-processing. Same story. You render the scene to a frame buffer, resolve it, read it back to apply the effect. Resolve it again, double the pain. That's why we say no post-processing on mobile. Not because it looks bad, because it kills your bandwidth budget. Now let's talk about the final blit. This is the thing Quest developers fear most. You deploy your game, everything seems fine, then you profile and boom, 7 milliseconds gone to a blit you didn't even know you were doing. A blit is just a copy operation. Unity copies your intermediate render result to the back buffer. Why does it happen? 4 common reasons. First, format mismatch. You're rendering to a texture format that doesn't match the back buffer. Unity has to convert it. Blit. Second, color space conversion. You're doing linear rendering on a device that doesn't support linear in the back buffer. Unity converts gamma to linear. Blit. Third, HDR. High dynamic range needs tone mapping. That's a blit. Fourth, certain URP render features, like the render objects feature, that can trigger a blit for free. Surprise! Some of these you can fix. Disable HDR if you don't need it. Avoid render features that force intermediate buffers. Use the right color space for your target device. Some of these you can't fix. If your hardware doesn't support linear rendering, Unity has to convert. That blit is the cost of doing business. Here's the mindset shift. On desktop, switching render targets is annoying but manageable. On mobile, every render target switch is a potential resolve. A resolve is memory bandwidth. Memory bandwidth is your enemy. Your goal is simple. Render directly to the back buffer every single operation, no exceptions. How do you check? Open RenderDoc. Look at the render targets. If you see camera color attachments changing, that's a red flag. If you see a final blit, investigate. Check your settings. Disable HDR, disable MSAA, see if it goes away. I'll give you a live example. I disabled HDR in my test project, rebuilt, captured a frame. The blit disappeared. Gone. But the shadow resolve? Still there. Because shadows write to a different buffer and Unity needs that buffer later. So what's the takeaway? Be aware. Know that tile-based renderers work differently. Know that resolves happen every time you write to a buffer that's not the back buffer. Shadows, post-processing, deferred rendering, all of them force resolves, and resolves cost you memory bandwidth you don't have. Use RenderDoc, check the render targets, count the resolves. Ask yourself, do I really need this shadow pass? Do I really need this post-process effect? Can I bake it? Can I fake it? At TheGameDev.Guru, this is the exact checklist we use when teams need fast wins on mobile. The fix is usually smaller than people think. Disable one feature, save 7 milliseconds. That's the power of understanding how your hardware actually works. Here's your action plan. First, if you're targeting mobile or Quest, open RenderDoc and capture a frame. Second, look at the render targets in the bottom panel. Are you rendering directly to the swap chain or are you bouncing through intermediate buffers? Third, search for the final blit. If you see it, check your color space, check HDR, check render features. Fourth, count your resolves. Every render target that's not the back buffer is a resolve. Ask yourself if you need it. Let me recap the 3 most important takeaways. 1. Tile-based renderers save memory bandwidth by rendering in small chunks and only writing to RAM when a tile is done. 2. Resolves, the operation that copies tile data to RAM, cost you half a millisecond per buffer. Shadows, deferred, post-processing, they all force resolves. 3. Your goal is to render directly to the back buffer on every operation. No intermediate textures, no final blit, just clean, efficient rendering. If you want a second pair of eyes on your mobile project, we do focused performance audits and training sprints at TheGameDev.Guru. We've seen this pattern across indies and AA studios. The fix is usually smaller than people think. If you found this podcast episode useful, You can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.